All right, let's outline the second derivative test. So we know that the second derivative of a function, f of x, can be written as f double prime of x. Okay, so this is Lagrange's notation, or you can think about this as d2x over dy squared. Okay, so you can also think about it like this, right? Now, what is the second derivative used for? Well, this is actually useful to determine concavity, specifically intervals of concavity. Right, and you can use it in conjunction with the first derivative tests, which were important for intervals of increase and decrease, as well as an idea of where our critical points lie. And we know that our critical points are points that indicate our extrema, right, or minimum and maximum points. Now, intervals of concavity, we can use the second derivative test. If f double prime of x is greater than 0, this represents an interval of concavity, right? If f double prime of, so this basically represents a concave up portion. Now, this is really useful because we can determine what type of increasing or decreasing function the function will look like, within a certain interval, right? If f double prime of x is equal to 0, we have a point of inflection. A point of inflection is a point where there is a change in concavity, right? There's a change in concavity at a point of inflection. So an example of this would be like if the graph was concave down and then it became concave up. So this would be a point of inflection. We use POI for point of inflection, right? Point of inflection. Excuse me. Or if we can have a concave up portion and then a concave down portion. So this is also another point of inflection. Now if f double prime of x is less than 0, we have a concave down portion of the graph. Okay. Now this idea of concavity is really important because sometimes we'll have an interval of increase, and there's two types of graphs that we can have. Like an interval of increase can basically look like either this shape of a graph, or we can also have this shape of a graph. Okay, so both of these are examples of intervals of increase. Similarly, if we have an interval of decrease, I'm going to do this out in blue, you can have an interval of decrease that either can look like this or that looks like that, right? The difference of this can be assessed if we actually use tangents to find the instantaneous rate of change. So if I utilize tangents here and I look at, let's do 3 different tangents at 3 different points. Let's call this tangent 1, slope of tangent 1, slope of tangent 2, slope of tangent 3. And the slope of a tangent is basically will assess the instantaneous rate of change. So you can notice here that the change in slope is increasing, right? The change in slope is getting greater, it's greater than 0, right? So we're basically increasing the change in slope, right? Like the change here, this is the first change. We look at the second change, you can see that the second change is greater than the first change, right? So this change in slope is increasing. So this is an increasing interval of increase, right? Now if we take a look at the other type of interval of increase, and we take all the tangents, and we'll look at 3 different points here. This is slope 1, slope 2, slope 3. We can notice here that the change between these two, let's call this the second change, right? We'll call this the first change, right? And this second change is actually less than the first change. So in this case, right, we would say that this is decreasing, right? This is a decreasing interval of increase, right? So this is basically an increasing interval of increase. This is a decreasing interval of increase. Likewise, we can do the same thing for this interval of decrease, right? So if I pick 3 points, and I draw tangents to those points, right? You notice here that, excuse me, these are negative slopes, so we'll call this M1, M2, M3. We can see that the slopes are getting less negative in the sense that they're becoming more positive values, right? So although the slopes are steeper, are getting less steeper, the negative value is becoming more and more positive, right? Here's an example. Like if slope 1 is equal to -2 and slope 2 is equal to -1 and slope 3 is equal to -1/2, right? Slope 3 is greater than slope 2 is greater than slope 1 in terms of just their pure magnitude, right? Although the lines are getting less steeper, right? This is basically the change, right? The change is greater than 0, but it's also the change is increasing, right? So instead of saying greater than 0, we'll just say that the change in slope is increasing, right? Just like in this scenario, the change in slope here is increasing. Okay, so because the rate of change in slope is increasing, we can understand that this is basically an interval of decrease, but it's an increasing or accelerating interval of decrease. And likewise, well, conversely, this is basically decreasing because you can see that the slopes are getting more negative, as in a sense that because the slopes are getting more negative, they're essentially getting smaller and smaller, right? So this is a decreasing interval of decrease. Okay, so both of these different types of intervals of increase and intervals of decrease are associated with concavity. We can understand this portion here, this is concave up, and this guy here is concave down. Right? And likewise, this is concave up, and this portion here is concave down. So it's very important to understand, in terms of the rate of increase or rate of decrease, it's really important to understand the concavity, right? So that's why the second derivative test can help us to do this, right? For the most part, when we are looking at intervals, we need to identify our points of inflection where we have a change in concavity, so we can distinguish between something that is concave up or concave down. Now you can use the second derivative test in conjunction with the first derivative test to have an idea, or you have a better idea of where maximums and minimums are located, where there's an interval of increase, decrease, whether that increase and decrease is increasing in its rate or decreasing in its rate. Okay, so we'll look at questions utilizing both of these tests, the first and second derivative test, to better suit curves.